Practice now number 2. A technician in a computer firm drove from his workshop to repair a customer's computer. On his way back, he stopped to repair another customer's computer. The distance time graph shows his entire journey. In part A, we have to calculate how long did he take to repair each computer. As we can see in the graph that he started his journey from point O. So point O will be his workshop, and he went all the way to point A. There he stopped and repaired the computer. A and B, A to B, as he is not covering any distance, the distance remains, the distance is the stagnant. So it's the time where he stopped and repaired the computer. So from point B to C, he again went back, and at point B, as we can see that the no distance is covered again, the distance is stagnant to C and D, therefore it will be the time at which he repaired another computer. And then D to E he went back. So all we have to do is how long did he take to repair each computer. Alright, we have to calculate A, B, the distance AB on the graph. So B is 30 minutes and A is 10 minutes, and the x-axis, as we can see, represents time. All we have to do is we have to minus 10 from 30 and we will have our time. So 30 minus 10 is equals to 20 minutes. This is the time he took to repair computer. Now part B, how far from his workshop was his first customer. I have told you before that his workshop was at point 0 and y-axis represents the distance. So we have to see the y-axis. First customer was at point A. Now we can see that point A is at 9 kilometer. So how far from his workshop was his first customer? The first customer was at 9 kilometer from his workshop. Okay, part C, we have to find out the gradient of each of the following line segments, stating clearly what each gradient represents. So each gradient, we have to find out the gradient of OA, AB, BC, CD and DE. So it's very simple. I have explained before that for gradient all we have to do is we have to drop a right angle triangle, and then we have to calculate rise over run, or we can say that we have to calculate vertical change upon horizontal change, right? So we have to calculate, let's do it roughly separately. First we will calculate the gradient of line segment OA. Now for OA, we have to drop a right angle triangle. So from A we will drop a right angle triangle at point 10, and that point will be our point B. Now I have written it roughly separately so that we can understand each and every coordinate of all the points. So point A is 10, 9, and point O is 0, 0, and point B is 10, 0. So as we know that gradient means rise upon run, then it's going to be AB upon OB. So very simple. AB is How can we calculate AB, line segment AB, right? It's the vertical change. So for right and yeah, for vertical change, we can see that it is 9 minus 0, and horizontal change is 10 minus 0. So this is our first gradient is 9 upon 10. Now point AB. For I have explained earlier that if a line is parallel to x-axis, its gradient is going to be what? 0. And I have explained this in the case of horizontal line and the vertical line in last lecture. Now for BC, I will drop a line from point B and make a right angle triangle. I am going to do it separately. So a right angle triangle is going to be BOC, and I will write separately the coordinates of each point. So the point at point B, the coordinates will be 30, 9, and at point O, the coordinate will be 30, 5, and at point C, our coordinate will be 35, for gradient 5. We have to calculate OB upon OC, and which is going to be OB is going to be 9 minus 5, and OC is going to be 35 minus 5. So it's going to be 4 upon 5. Gradient of CD, as we know that it's parallel to x-axis, gradient of CD will be 0. Gradient of DE, again same method, just drop a line from point D. Let's do it separately. D, E and O is the right angle triangle, and the coordinates of point D is 55, 5. Coordinate of E is 62, 0, and coordinate of point O is 55, 0. So all we have to do is rise upon run, calculate rise upon run, that is OD upon OE, which is 5 upon 7. data.
Thank you for watching. Subscribe for more updates.